IT, programming, DevOps, cloud, software, coding. Did you ever want to simply understand what all these words mean? Or have you ever wanted to start careers in any of this? Hello and welcome to a video which explains the above in simple words and using simple language. Right, so where do we start? You want to become a DevOps. So what is DevOps? Wait a second actually. Let's go backwards. What is programming? No, wait. What is a computer? Let's start from there. Let's start from the very beginning. What is a computer? A computer is a machine made up of two main parts, hardware and software. First, there's the hardware. It's the physical parts of the computer that you can touch and see. At the heart of every computer is something called the CPU, which stands for Central Processing Unit, the processor. It's like the brain of the computer. Then there's the monitor, like the computer's face. It shows us what the computer is thinking or doing. Next, we have the keyboard and mouse. They are like our tools to talk to the computer and tell it what we want it to do. When we put all these hardware parts together, we get a computer, a powerful machine. Now let's talk about software, the other part of a computer. Hardware was the physical things, but what exactly is software? Software is the virtual things that makes the hardware execute tasks. Without software, a computer is just an object. But you need software to interact with it. Software is a set of instructions that tell the hardware what to do. The first type of software to mention is called the operating system. It's the master software that manages all the other software on the computer. You surely heard about some of them. Microsoft Windows, Linux or Mac OS. One tip for you, don't stick to... Another type of software is applications, or apps for short. These are programs that we use to do specific tasks, like browsing the internet, writing documents, or playing games. Without software, a computer would be just a bunch of electronic parts. It's the software that gives the computer its functionality and usefulness. So this is what we will talk mostly about in this course, software. Let's explore it further. We already said that we have the operating system, which provides a user interface for us to interact with the computer. That means you can see something on your monitor and you can type something on your keyboard. So what does that enable us to do? Well, we can now install application software. As we mentioned, these are the programs that we use every day for various tasks, like browsing the web, editing documents, sending emails, and so on. Okay, this is what we are interested in. Most of the work today in the computer world revolves around application software. How to create the application software, how to make it available to people, how to maintain it, how to secure it, and so on. Let's start with how to create it. What do we actually have to create? We have to build something that tells the computer what to do. But how do we talk to computers? The operating system gives us a very basic way of talking with computers. But it's not necessarily English. It's in a different language. It's not complicated. You just have to learn how to speak or type that language. For example, you can tell the computer to add two numbers, or you can ask the computer to display the current date. And you can do this by typing some commands in a user interface provided by the operating system. So this is how we build applications. Similarly to this, the operating system provides certain basic commands that you can interact with the computer. But proper programming languages have been created to help users write applications easier. Programming? Yes, programming. The action of creating applications is called programming. You are programming the computer to do something. So, programming languages are themselves software that someone created in order to help engineers to create applications easier. Some popular examples are Java, HTML, or Python. Okay, so what do they actually provide? They provide a way that engineers can write some simple commands which will instruct the computer to do more complex stuff. So when you are writing a programming language, it's called coding. The text that you are writing in a programming language is actually called code. Let's take an example. An engineer desires to create a website. The most popular language for creating websites is called HTML. So he will write text code that will represent the components of the website. A title, some headings, some paragraphs, some picture representation, some buttons, and so on. The code itself is just pieces of text, but it will be interpreted by the programming language software in order to transform that piece of text into the desired result, like a web page. That's an example of programming, writing text in a programming language. It would be good to mention that the people that are writing code to build websites or applications are also called developers or devs. Okay, understood. But where are these developers writing their text? That's a good question. They could write it in the command line interface provided by the operating system. Or there's some basic software that comes installed with the operating system, like Notepad. But the proper way of doing it is by using code editors. People have created software called code editors that allow developers to write code in a much easier way than in Notepad. A lot of pre-built functionality has been created in these code editors to make their lives easier. That's nice. So let's recap for a second. After an operating system is installed, engineers, called also developers, are using code editors to write code in a programming language that they have chosen in order to develop more software applications. That is called programming. Using this principle, your mobile applications and your websites and any other software that you use is being created. That's a good recap. So let's go a bit further than that. Developers write code on their laptop, but oftentimes more developers are working on the same project. How do they get along? Well, for that they use a special central place called versioning control system. It's like a big online notebook where they can share their work with each other. It's called a repository also. It's a place where developers can store their code and have all sorts of functionalities for collaboration and maintenance of that code. The most popular versioning control system is called GitHub. But all this does is just storing and maintaining text. Right. So we saw that developers write their code locally and then they put it in a central place where they can combine their work. But that's not the final destination of the code. The code is supposed to live in some place where it will produce an application and clients will be able to access it from their computers. The process of putting the code into such a location is called a deployment. You deploy an application. where do you deploy it? You deploy it to a server. A server is something very similar to the laptop where the developer wrote the code, but much more powerful with bigger processor, higher memory, and one that is typically available 24/7. And developers are aiming to deploy their apps to the servers, which will make available the apps to the intended clients. Okay, but these servers, they also need to have an operating system installed. They also need to have some software installed that is able to support the applications. Who takes care of that? Very, very good question. This is just the tip of the iceberg. We're entering another world. Servers need to be maintained. Servers have errors. Servers need to have network connections and security installed. At times, more servers need to be added, and a lot of other functionality around the server is there. And also, you will need to have certain servers for development stage, certain servers for a testing stage, and certain servers for production stage, where everything is ready for the client. Applications need to progress from one stage to another, meaning to be moved from one server to another. And someone needs to do this in order to help developers execute their application and make it available to the audience. Traditionally, the team that handles such are called ops. Well, that sounds simple. Dev people are the people that develop the applications, and ops people are the people that take care of the operations around the servers where the applications would live. Exactly, that's it. Well, that used to be many years ago. There was so much friction between these two teams, and the things were going way too slow. And people wanted to increase the speed of the whole process. So they tried to automate things. To automate what? Coding? Well, anything that is possible. Anything to make things faster. From coding to the way applications are tested, to the way applications are deployed on the servers, even creation of the servers and operating system installation and networking and security around the servers. Anything. People even looked into some way to compress their application so it can be easier copied into the servers. Oh wow! So who handles this automation? The dev or the ops? Neither. A new role and a new team has been formed. Guess how it's called? DevOps. DevOps. The ones that sit between dev and ops. Okay, so let's talk a bit about this automation. And let's start by focusing on the automation provided for the ops side. And we will start with a small story. Welcome to Dougal. It's a lovely company that handles payment transactions for many customers. They are located on the Goodall Street and over 400 employees are working there. Also in the basement they have a number of servers where they are storing all their data. Black Friday is 5 days away and they have just realized that their servers will not be able to handle the traffic this year. They urgently need to increase the number of production servers. And here they start. They order 10 additional servers, they order networking equipment, large hard drives, and are informing their engineers of the need to work long hours. But the engineers respond by raising the risk that the time might not be sufficient. Irrespective, they continue. 2 days later, all the equipment arrives and the engineers start working. Well, what they need to do is to install the operating systems, connect the computers to their network, install the databases and have those databases in sync with the others, install the libraries and correct language versions, security software, monitoring, logging and alerting tools, together with other necessary software. And only then they will be able to install the production software
on those new servers. After all this installation, they will be able to assign QA to perform their test, and only then they will be able to finally release. Because of the amount of work, pressure builds up, and Black Friday turns out to be a complete failure. Google is now looking to fix these problems for the future, especially with their plans to expand the business into an additional country next year. In a small consultancy session, one of the first questions they are asked, "Have you considered the cloud?" And they simply respond, "What is the cloud?" The cloud is a global network of servers around the world acting as a massive hard drive. Okay, let's keep the language simple. So, the cloud is a group of servers and services that you can make use of them. The servers are physically spread across the globe and connected together, but you can virtually access those servers. So, you can choose a cloud provider and then purchase virtual servers, as many as you want, with the specifications that you desire, for a period that you desire, with the attached storage that you desire, with the desired operating system. Okay, so that's the cloud. Well, just a part of it. That's the compute part. But they also offer you networking services. So you can have network isolation, attach your computer to a private network, have a router around it. Your server will get public and private IP. You can make use even of load balancer, DNS, and other services. Then you have the security section, where you have services like firewall, encryption, backup, DDoS protection. And then they provide storage capabilities for media, for file, for text, even managed databases. And services like monitoring, logging, alerting, they all come out of the box for your own benefit. Well, that's actually a good review. The cloud refers to servers and software services installed on those servers that are available for you virtually. Most of these services can be categorized into compute, storage, networking, operation management, big data, AI, together with identity and access management around those categories. So looking at the problem Docker had this Black Friday, I think the cloud would really be able to help you increase your speed to the market, scale in a much faster and easier way, and even use the resources only for a period that you need, so you don't have to pay additional when you don't actually need it. And one more thing, you are saying that Google is located on the Goodell Street, and you have your data center there and only there. What would happen in a case of a disaster? Wow, I never thought of that. But what I can say already is that Google's problem that we had this Black Friday, together even with our future expansion plans, I think cloud can solve that for us. I really want to learn more about the cloud.
I hope you enjoyed the story about the cloud. Alright, so the cloud has taken off quite a lot from the hands of people in terms of physical activities. But not only. Together with the cloud, some more automation has been introduced. In cloud, it's possible to define the configuration of the infrastructure desired through code. That means that you are able to write code in a certain language to say, I want so many servers with this specific operating system, with so much memory, and I also want some networking routes and some security and a database with some configuration. So you can cover servers, networking, security, storage, and pretty much everything in terms of infrastructure. And you can write all this in code. Okay, so what's the value of that? The good thing is that once you write this configuration as code, you're able to eliminate manual creation through human clicks. This will eliminate the risk of human errors. And when you want to do it for many resources, you don't have to repeat yourself and don't have to waste the time. Another important factor is that once you define the entire infrastructure through code, you're able to create it in different places. You will need a place for development, for people to internally work. You will need a place for quality assurance people, for them to test the work. And you need a space for production, where the client will access the applications. These places, they are called environments. Dev, testing, prod environments are the typical ones. Wow, that's a lot of information. It is, isn't it? Right, so the infrastructure is written as code. Is that code stored still in a versioning control system like GitHub? Exactly. Just like on the dev side. Okay, but there's still one bit that we don't understand. From a place like GitHub, how is this code, which is just text, transformed into infrastructure in the cloud? How are the servers, for example, created? Amazing questions, worth explaining properly. GitHub and similar systems, they have integrations with some tools which are called automation servers. The automation server is just like a normal server where you can execute commands. So engineers, usually DevOps, they write commands which talk to the cloud provider to tell it that they want the resources defined in the infrastructure as code files to be created. What happens is every time a change or something new is added to the repository, the automation server is notified and the automation server will execute those commands that the DevOps people wrote. And that happens automatically. This process, where certain commands are executed every time a change happens, is called a pipeline, a set of instructions. That's nice, but wait, couldn't this be done also for the development for their applications? Absolutely. You can create pipelines for infrastructure and pipelines for applications. Every time a change happens to the code of an application, you want to have certain actions that will be repeated, like building or testing the application, or packaging the application, or even the process of deploying the application on a server. Everything can be automated. I believe by now you understand the flow. So let's do a final recap. Developers are using code editors to write code in a chosen programming language and store that code in a central location called a repository. The DevOps team configure an automation server to watch that repository for updates, and automation pipelines are being executed in order to test and package the code and store the artifact somewhere. Upon success, the automation pipeline proceeds to deploy the application on the desired server. These servers are provisioned also in an automatic fashion, pipelines executing infrastructure as code to create cloud resources that include servers, networking, security, database, and other resources that will be helpful for ensuring that the application is available, reliable, secure, and the system is observable. The infrastructure side is the railway, and the applications are the trains that will run on the railway. My name is David, and I'm a passionate technical person that loves to explain complex stuff and make it easy for people to understand. I have loads of students that desire to embark in some of these careers, and I thought I would make a course focused on DevOps to help more people in their journey. If simplicity is something you're looking for, you're welcome to join the course. You can contact us for details.